Hi and Assalamualaikum. My name is Aiman Fatina Binti Muhamad Kamal. My matrix number is DE20094 and I will present on my project 1, okay, which is develop a prototype of an unmanned water surface garbage cleaning robot using PV panel. Okay, my supervisor is Dr. Jabbar. Okay, so for the presentation outline, okay, we have 5 part, which is chapter 1 is the introduction, chapter 2 is the literature review, and chapter 3 is the methodology, and chapter 4 is the discussion, user discussion, and then chapter 5 is the conclusion. Before the introduction, so waste is a chronic pollutant that has not been entirely resolved. Often discovered trash from numerous locations thrown into rivers, waterways, and rivers. Okay, so according to the World Health Organization (WHO), okay, 22% of all communicable disease infection in human are waterborne. Okay, due to the excessive growth in algae, okay, the oxygen content in water is decreasing, which may result in death of fish and other aquatic species. Okay, so this project intend to propose a solution to the problem of waste in water area by developing water surface garbage cleaning robot to overcome this existing issue. So for the problem statement, okay, the first one is waste is one of the major cause of water pollution. The second one, high cost and high risk to use manpower. According to the Straits Times, okay, over 6.5 million were spent by the Malaysian government to remove pollutant from Sungai Kim Kim, where chemical were illegally dumped. The second one, according to Miss Marisa Perry, who is one of the volunteers for Econites, okay, the Department of Irrigation and Drain, DID, spent over 5,000 ringgit every month to collect and dispose the rubbish. Okay, this is because they use manpower. And then the third one, most robot use battery. And then the fourth one is to increase the operation hour by integrating PV panel. The objective is first to design a small scale water surface garbage cleaning robot. And the second one is to develop the prototype of the robot. And the third one is to increase the operation hour of the system with integrated photovoltaic system. Okay, for the scope of work, okay, first we use Arduino microcontroller, and then we use 12 VDC motor, and then add one PV panel, and then we use the lithium battery, and then the estimated size for the robot is 0.8 meter length, 0.4 wide, and then 0.6 height meter. And then this project we will conduct in UTHM lab. Okay, for the literature review, this is comparison between previous project. Okay, this is Aqua Multi Robot System Lake Cleaning. Okay, this is the prototype. Okay, first it is fully controlled, fully automatic and manual by remote control. And then this is the cleaning mechanism using a conveyor belt and then net trapper. Also, it has a tactical sensor and then propeller for the robot to move. Okay, so it is easy to control. Waste can be easily collected, and then, however, it cannot collect chemical waste or small particle waste. Okay, the second prototype is development and implementation of a marine robotic algorithm validation testbed. Okay, this is not for cleaning purposes, but only for monitoring the pH, okay, purposes, okay. However, this is this is powered by the solar powered, okay, over here, okay, and this is fully automatic, okay. So the disadvantage is this cannot collect waste, but the advantage is can be monitored the pH of the water and has GPS for monitoring location. Okay, next is ambitious clean up robot. Okay, okay, this prototype same like the first one, but this part, okay, the cleaning mechanism part using a propeller with a storage tank. Okay, this is manual and controlled by remote. Okay, so it has double propeller with motor for cleaning purposes. Okay, and then this also has a solar tracking system. Okay, over here. So the for one is design and hydrodynamic modeling of a leg surface cleaning robot. Okay, this same like the first prototype, which has a conveyor belt and a storage tank. Okay, and but this structure is more stable and a better chassis and has a bigger white space over here rather than the first one. Okay, two robot is actually the same, but this one is a modified one. Okay, it is modified with YOLO V3 detection method. Okay, this part is using a robotic arm. Okay, the cleaning mechanism using a robotic arm and a storage tank also. Okay, and this robot has a vision-based steering. Okay, next the prototype. Okay, this board prototype are same like the first prototype. Okay, this one use a conveyor belt and a storage tank and can control via Bluetooth. Okay, but this advantage is very fragile, as you can see over here. Okay, it only use the styrofoam, and then this part is using a conveyor belt and then a treponet. Okay, and also have a sensor. Okay, but this conveyor belt is different from the prototype one and other um, prototype because it use a scooping method. Okay, like here when the waste go here and it will go up here. Okay, and then next, okay, this prototype a floating waste scooper robot on water surface. Okay, also use the same method like this one. Okay, which is use a scooping method. Okay, and then this one, autonomous water quality monitoring and water surface cleaning for unmanned surface vehicle. Okay, this cleaning mechanism use salvage net. Next, this is a remote control watercraft for water measurement. Okay, this is like the second prototype which are used to monitor the water qualities. Okay, there's none cleaning mechanism and the controller using an antenna. And then this is a design of low-cost unmanned surface vessel for water surface cleaning. Okay, and this also the controller is full coverage collecting path and the cleaning mechanism guided rod, guided roller, and collecting bag over here. Okay, and then this one is an automated surface water cleaning robot for pond and water rivers. Okay, okay, the controller is a Bluetooth module. Okay, then the cleaning mechanism also use like the prototype one, which is conveyor belt. Okay, and then the last one is aqua custodian robot. Okay, like this. This is use scooping method for software requirement. First, I use Microsoft Word to do my report. The second one, I use Google SketchUp to design the robot. The third one is using Arduino IDE for the coding of DC motor. And then fourth one is the Microsoft PowerPoint. First to do the circuit connection, and then the second one is to do this presentation. Okay, for the upcoming project, okay, software requirement, I will use freezing. Okay, this will be more proper to to construct the circuit. And the second one maybe using Proteus for simulation before the troubleshoot of the motor and robot. And the last one is Microsoft project for more proper Gantt chart. Okay, for the methodology, okay, this is my general flow chart. This is my current project, which is I already done the literature review, the calculation of parameters, the algorithm coding for DC motor speed, and then lastly, design the structure of the robot. Okay, for PSM2, I will do the hardware information, coding and troubleshooting, and then final report and then presentation. Okay, so main task I have been done is the calculation, the coding, and the design. So for the PSM2 will be the development and the testing and troubleshooting. So for the calculation, first we need to determine the total weight, force, and average speed. Okay, this is so we can find the suitable component for the robot. Okay, first is the robot is estimated to be 6 kilogram, and then the load can carry by the robot is estimated in 1.5 kilogram or in 50 Newton. Okay, so the average speed of the robot is 0.5 okay meter per second. Okay, so first we need to determine the total work. Okay, so the total work, okay, when we times 50 Newton with the average speed, we will get 7.5 total work nm, and then just by that we can calculate the power. Okay, the power. So the power we can gain by work divided by time, which is 1 second. We get 7.5 watts. Okay, so for the PV panel, okay, we use the monocrystalline, okay, because it has 20% efficiency. So based on the radians, okay, 1,000 radians times with the 20% efficiency, we will get 200. And then next, area for the PV panel to produce at what? Okay, so by doing the past calculation, we will get this 200, okay, times area, we will get at once. Okay, so how to find area? This is mathematical, so we will get 0.04 meter squared. Okay, so surface area for the PV panel, which is this is the upper part of our robot, okay, the top part. So the width times length, so equal area. So 0.1 times 0.4 meter equals 0.04, which is over here. So this is our surface area that we can put the solar panel and can produce 8 watt. Okay, so for DC motor requirement, okay, this we gain from the data sheet, which is we will get 1.8 watt per motor. For the battery, okay, so we select a lithium battery, okay. So we use 2 battery and we put it in parallel. So we will get 2.4 Ah the capacity. Okay. So estimate operating hour on ideal cases. Okay, how to calculate it is power equal battery divided by motor. So this is from the data sheet. Okay, 0.15 amps. So we will get 16 hours. Uh, for the motor to move forward, backward, left, and right movement, a motor driver is required. Okay. This project selected a 12 DC gear high torque motor because it has a high torque and can support 0.5 kg of weight per motor. Okay. The project weight is 1.5 kg, but because it is aqua based, it weight will be less than it is when on land. Okay. So the driver is a dual H brake motor driver which allow speed and direction control of 2 DC motor at the same time. Okay. So the driver can drive DC motor that have voltage between 5 and 35 volts, and then the driver has 2 amps current per output. Okay. Okay, this is the flowchart of the coding for DC motor speed. Okay, first we set up the pin. Okay, and then the second one, we set the output and input, and then we set the initial rotation of the direction. So this is initial, is to move forward. And then we set the initial value for the potential value, which can go fast, medium, low. And then we also set for the button. Okay, so when we press the button, the motor will go reverse. And if we press it again, it will go forward. Okay, so for the design idea, it is based on 4 characteristics, okay, based on the previous project. Okay, for the best structure, okay, I choose this design and hydraulic modeling of a leg surface cleaning robot, okay, because it is look more stable and has a better material and a good chassis. Okay, another reason why it is okay because it's stable because of the bottom area. Okay, it is big, so it can able to support all the component. Okay, the next one is the wheel. Okay, for the wheel, I choose the floating waste collecting robot with best water monitoring system because has a good wheel base because it can move easily with flapper around the wheel. This will make the movement of the robot more precise. And then for the solar panel, I choose the development and implementation of a marine robotic algorithm validation testbed robot. Okay, so the top of the surface robot is suitable to put a solar panel. And then for the cleaning mechanism, I use the first prototype, which is the aquatic multi-robot system leg cleaning robot. Okay, that robot used conveyor belt with net trapper. The net trapper was changed into the box due to protect the microcontroller at the back of the robot, back here. Okay, so the size of the robot is based on the previous calculation, which is over here. Okay, over here is the 0.4 and 0.1 meter. So we can put at one solar panel over here. Okay, so for the primary zone. Okay, this is the hardware list. Okay, to create the DC motor, but also I put the solar cell over here because I already calculated it. So it is around 314 ringgit. Okay, but this will be expected to be more in project 2. Okay, but I do the hardware. So this is the circuit connection. This is for one DC motor. Okay, for two DC motor, we will have two connection here. Okay, this is to set the speed of the motor, fast, medium, and low. Okay, this can be pressed. So the button will change direction, reverse or forward. Okay, to validate the parameter, okay, we need to test the motor. Okay, we actually run 6 condition, but 2 condition I cannot take picture because I need to stop the motor. Okay, first is no load, which is direct connection battery and motor. And then the second one is with load. So the motor we added a load, and okay, and the third one is stall where we completely stop the motor, and the fourth one when it is connected to the motor driver. Okay, so we have the full speed, medium speed, and low speed. Okay, for first we test is the RPM, which is using the tachometer, and then we check the voltage, and then we check the current. So this is the value we have obtained from the test, which is when on load, it is 176.8 RPM, 0.05, and then 11.43 and 0.6 watt. This is calculated. Okay. So after that we want to compare with the datasheet. So the difference of the datasheet and the measured parameter can be slightly different, such as the RPM, which is in datasheet is 200 RPM, while in the measurement is 176.8 RPM. For the no load current in datasheet is 60 milliamps, while in the measurement is 50 milliamps. Okay, with the load measurement in datasheet, okay, is 160 RPM, while in the measured parameter is 156 RPM. For the current with load in datasheet is 150 milliamps, and the measured value is 100 milliamps, which is the same. Lastly, the output power at the datasheet is 0.8 watt, meanwhile the parameter is 1.7 watt, okay, slightly higher. For the design and material, okay, all component and part using different kind of material. Okay, first the conveyor belt. Okay, we'll use rubber and belting so it can easily carry the weights. Okay, the body of the robot. Okay, we will use PVC, styrofoam, and lightweight material. And then the third one is for this wheel. Okay, we will use 3D printer material so we can customize the wheel. Okay, this is the side view of the design. Okay, the back view, so we can put the microcontroller part over here, and then the front view. Okay, and then the top view. Okay, the top view where I can put the solar panel over here. Okay, for the conclusion. Okay, in this project, although the hard work were given to build a robot that able to clean water surface from waste, okay, from all the previous project that has been reviewed in the review, all the data has been gathered, and it is very useful to build and design the robot. Next, in order to develop the robot, all calculation of parameter for selecting the component has been done. Although the specific that has been desired, the next phase of the project is to create the coding and wiring the DC motor speed and movement. After that, the robot structure is designed using SketchUp software and able to see 3D model of the robot. Lastly, the primary result testing the DC motor to know the specific value parameter of the DC motor in this project. Okay, so the total cost to make this DC motor is 300, 14 and 40 cents. Work recommendation for project 2. Okay, first we want to construct the water cleaning robot. The second one, do stability test and floating test on the structure of the robot. And then the third one, we will integrate the DC motor that we have been done for this project one in the robot. And then four, we do troubleshooting and testing. After that, we integrate the solar in the system. Okay. The last one is introducing IoT to control the robot. That's all from me. Thank you very much.